Welcome to a lesson on trapezoids. It is another special quadrilateral or four-sided figure. This is the definition that I am going to use for this course right here. And when I say I'm going to use it is because it turns out within the math field or within mathematics, there tends to be a little bit of argument about what a trapezoid is. Some define it differently. Some define a trapezoid as a quadrilateral with at least one pair of parallel sides. I don't like that definition. I think it muddies the water, but you know what? You can make up your own mind. So I'm going to say exactly one pair of parallel lines. Okay. Notice in the three examples below that we have exactly one pair of parallel lines. In the first picture, we have the top and the bottom of the trapezoid are parallel here and here. Okay, that's called a trapezoid. In the second picture, the trapezoid, the bases, they're actually still bases, but they're stood on end. So we're going to call this a base side. We're going to call this a base side. Strangely, they have two bases, and they're always going to be those parallel sides. So even when it's turned sideways, we're still going to have these two bases. And then in this last example here, you have another special case, which we're going to look at in the next lesson. It is when you have a trapezoid with the pair of parallel sides, but you also have the two non-bases called legs. They're going to be equivalent to each other, and that's called an isosceles trapezoid. Let me show you another picture of that. Oop, down below here. All right, here we have that isosceles trapezoid with base. We have something called base angles. All right, and then the legs there. Let's take a look at GeoGebra for a second. Here I've constructed a trapezoid, so no matter how you move it, the two opposite sides are parallel. All right, this top base could be extremely small. That's an extreme. It also can be larger or wider. The only thing it can't be is if I were to move it about right in there. I'm eyeballing it. Notice how it looks like a parallelogram? That's the only exception. You can't make it a parallelogram because then it would have two sets of parallel sides. So it can go further than that. That can be a trapezoid there as well. You notice you still have just two parallel sides. So, but any of those would work. And also it can be any orientation. So if I were to turn it like this or turn it like this or whatever I were to do, if I put it like that, notice still DE and AB are parallel. So that is what makes it a trapezoid.